And here it is, 3x to the fourth plus 11x cubed minus 20x squared plus 7x plus 35. Everything divided by x plus 5. So the question here is this division, or can this division be performed with both or just one? And how do we know? So my question is, can I use long division and synthetic division, or one and not the other? I can use both. Why?
Because the coefficient of x is 1.
Because the denominator is x minus a. If the denominator does not look like this, I cannot use synthetic division.
So if it's squared, you cannot.
Exactly. If it's squared or if it has 3, blah, 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 then I will have to perform some other operations before I use synthetic division. Correct. So this division can be performed with both. Which one would you like us to start with? Would you like to start with the long division or synthetic division? Okay, in that case, let's start with the long division. The answers have to be the same. Okay. So if you remember, I asked myself a couple of questions. First question that I asked myself is, are these in descending order? Yes, they are in descending order. And my second question is there a missing term from the top? No, because the degree is 4. 4, 3, 2, 1, and 0 degree. Very good. So then I can continue by writing 3x to the fourth plus 11x cubed minus 20x squared plus 7x and plus 35. And x plus 5. So the first question I ask myself is what?
What number do you multiply x plus 5 by to get 3x?
What quantity I multiply x by to get 3x to the fourth?
Just x. 3x cubed.
Thank you. Do we agree with 3x cubed? Yes? Now we have to go back and distribute to both, change the sign, and write below like terms. 3x cubed times x is 3x to the fourth. I have to subtract. 3x cubed times 5 is 15x cubed. I have to subtract. Do we agree with this step before we proceed? Yes? Okay. So then these two go away. I perform the operations I see. I get negative 4x cubed and then minus 20x squared. What is the next question I ask myself?
What do you multiply x by to get negative 4x cubed?
Perfect. And remember, we do not lie at the top.
Minus 4x squared.
Awesome. Now I have to go back and distribute negative 4x squared to these two terms, change the sign, and write below like terms. Negative 4x squared times x is negative 4x cubed, but I have to write positive 4x cubed. Negative 4x squared times 5 will be negative 20x squared, but I have to write 20x squared.
That goes away then.
Good, that's nice, no problem. I bring down the next two in line. We can always go back and check, and we'll actually check with a synthetic division. So now x times what is 7x?
7.
I need sign. We do not lie at the top.
Plus 0x squared.
Plus 7. So 7 times x is 7x. I subtract. 7 times 5 is 35. I subtract. What is the remainder of this division?
None.
Nothing. 0. So we claim, or maybe I claim, I have no idea whether I'm correct or not, but it's very easy to check. So for now, I claim that this division gives us 3x cubed minus 4x squared plus 7. Now, a good question here before we look at the synthetic division and before we check. What can you say if the remainder is 0? What can you say about x plus 5? What does x plus 5 represent for the top? Not Tom.
It's a factor.
Excellent. So in other words, this times this should give us this. Awesome. Yes. So x plus 5 is a factor of 3x to the 4th plus 11x cubed minus 20x squared plus 7x plus 35. Of course, I haven't checked. Good. So now I would like to go ahead and check with the synthetic division. Is there another way of checking just the remainder? Let's say I'm interested to check if the remainder is really 0. Is there a way of doing that?
I think.
Yes? If I denote the numerator by p of x, what do I have to calculate? I have to find p of
X plus 5. No.
I only can plug in a number. I mean, I shouldn't say that, but I have to plug in a number.
Fine.
But remember, this is x minus a.
And any number with a
Say it again.
negative 5.
Yes, indeed. And if this is 0, then the remainder is 0. I don't know yet. So I will plug it in and see what I get. So 3 multiplied by negative 5 to the 4th power plus 11 multiplied by negative 5 to the 3rd power minus 20 in parentheses negative 5 squared plus 7 times negative 5, which is negative 35, and then plus 35. When I click enter, if I get 0, then I'll say, yep, I think my calculations are correct. And now I have a third way of checking, which is the synthetic division. So what goes in the box?
Negative 5.
Indeed. And what are the coefficients that I have to write at the top?
3.
Yes?
11.
Yes?
Negative 20.
Yes?
7.
Yes?
35.
Correct. So the algorithm requires us to copy the first coefficient always. And then we multiply negative 5 by 3 and we get negative 15. And then we get negative 15 plus 11, which is negative 4. And then negative 5 times negative 4 is positive 20. And then I get 0 here. And then you get negative 5 times 0 is 0. 7 plus 0 is 7. And negative 5 times 7 is negative 35. I have to get the same remainder. And here is the quotient, 3, x to the 3rd. How do I know it's x to the 3rd? Because I divide degree 4 by degree 1. So I have to have 3x to the 3rd power. I have to have minus 4x squared. I will not have a term with x, and then plus 7. Ryan, you feel a little bit better about this? Can you tell me what was not very clear?
I don't think I focused enough during class during the synthetic part.
Okay.
And the long division, I just didn't, like, I hadn't used it in a while, so.
I'm also learning from you for the next class.
Right.
So if you're telling me, okay, this was not very clear, then maybe next time I teach this, I will think in terms of, okay, Ryan said that I didn't show this clearly, so maybe I should do a better job.
Yeah, I don't know, it was just kind of rust on like not knowing in the long division part of what to multiply to what and then subtract 5, but I got it now.
Is it better now?
Yeah.
Okay, very good. Is there any other topic before we choose something else? Is there any other topic that you would like to go back to? Anything else that you remember not having enough practice or me not presenting enough. Anything else from your test 2 that you would like to go back to? No? Okay. What about graphing a rational function? What about graphing a polynomial function? Can you come up with anything, or you want me to choose? Okay. On page 361, I would like to look at a word problem. I don't remember if we did this or not. You can stop me and say we've done it and we choose something else. Let's say 68 on page 361. You have 80 yards of fencing. Right? To enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. And what is the maximum area? Okay, let's read the problem one more time. I took notes, so I don't have to look at the book again. So let's read it one more time. You have 80 yards of fencing to enclose a rectangular region. Find the dimensions of the rectangle that will maximize the area. What is the maximum area? Okay. So I'm going to picture a rectangular region or garden, whatever you want. So this is the rectangle. And this is what I would like to maximize. Max the area. And I would like to use everything. I would like to use the whole thing that I enclose here, starting from this point all around, coming back to this point. I like to use 80 yards. And I just want to make sure that I find the length and the width that will give us, for sure, the maximum possible area having only 80 yards of fencing. Okay, so what are the variables in this problem? What am I looking to determine? Exactly. So I'm going to denote this by x and this by y. Awesome. I don't have the x, I don't have the y, I don't have the length, I don't have the width. So what is the first relationship that I could write knowing that all I have is 80 yards of fencing? Can anyone give us a relationship that we can write?
2x plus 2y.
Very good. The perimeter is nothing else but 2x plus 2y. And indeed, 2x plus 2y must equal 80. We are using it all. We go all around the circumference of, or the perimeter in this case. Circumference is used for circle. The perimeter of this area. Awesome. Now, of course, I'm looking at this equation and I know those three concepts. Factor, simplify, clean it up. How will I, is there anything I can do to make it easier?
Divide both sides by 2.
So I have x plus y equals 80. Good. Oh, of course. Thank you. Sorry about that. Okay, so I took care of this. I took it, the rectangular region. Now, here's where I'm at. I'm asked to maximize the area, but I don't know the area yet. How do I write the formula for the area of a rectangular region? Anyone? Good, perfect. So then this area, A, is x times y. However, this is the variable which is the function. This is the first variable, which is x. And this is the second variable, which is y. Well, one of these two, I should say three variables, one of these three variables has to go away. Because we don't know functions of two variables. That's in Calc 3. So one of these two has to go away. How do I make one of these two go away so that I have a function with one variable? Any suggestions? I must use what I have.
You can express y as y equals 40 minus x.
Absolutely. So this is 40 minus x. I solve the equation I have, x plus y equals 40 for y. Awesome. And in this case, I will make y disappear. I'm replacing it by 40 minus x. Awesome. And now I can say that this is a function only of x. I could not write that here. So now I have x, parentheses, 40 minus x, equals. I have to distribute, because I really don't see the function yet, and arrange it in descending order. So this is 40x minus x squared. And now when I arrange it in descending order, I see it's negative x squared plus 40x. And now I'm going to think, what type of function is this? I am absolutely certain you know what function it is. I have no doubt. Thank you. Good. So then, coming back, I'm done with this, I'm done with this, I'm done with the area, and now I need to maximize it. And then I will find it. How do I find the maximum area for a quadratic function? How do I find the maximum for any quadratic function? How do I calculate? What do I have to write and find in order to determine the maximum? By the way, does this function have a maximum? What if it has a minimum? Then we're wrong. That's not the correct function. Do I know whether it has a maximum? What if it's a minimum?
Definitely has a maximum.
Because?
Negative.
Because the leading coefficient is negative. Awesome. Perfect. So now how do I find the maximum? So we are on the right track. The function looks good. But now I need to find the maximum for this.
I'm going to use the vertex.
Very good. The vertex will give us the maximum. Awesome. How do I determine the x-coordinate of the vertex? The vertex is the only point to look for. How do I find the x?
Negative b over 2.
Thank you, Eddie. Negative b, here's b, over 2 times a, which is negative 2, so the answer is 20. What does this mean? This means x, this, which means this. This is our x. And how much is y? If x is 20. Also 20. Good. Okay, so x equals 20 yards and y equals 20 yards. These are the dimensions that will give us the maximum. But now the question is, what is the max area? How do I determine the maximum area? What do you think? Right, or go back and replace it in here. It's the same thing. Because x times y is the area we created, it's the function that we created. But this is the easiest thing to do. So 400. So I would write as the final answer, using 80 feet of fencing, we can enclose a maximum area of 400 yards squared with dimensions 20 by 20 yards.
Why is it yard squared when you're using defense?
Very good. Because when I multiply 20 yards by 20 yards, I get 20 times 20 and yard times yard.
Yeah, but should those x's and y's be in terms of feet then, not yards? If you only have 80 feet, since you can't have.
We have 80 yards.
Oh, okay, so. Then this is gonna be using 80 yards of fence?
Yes.
80 feet.
Oh.
That makes more sense.
Sorry. I'm sorry. Of course. Can get away with anything. And I don't want to. Thank you. Yes, of course. Of course. Of course. Of course. I'm sorry. Good. Very good. Okay. I'm going back to other topics. And I would like to review the difference quotient. Let's review the difference quotient. I'll find it. Maybe. Yes, I did. Okay. It's on page 252. Let's say problem 77, in which we have f of x equals x squared minus 4x plus 3. And we're asked to find and simplify the difference quotient, and that will be given to you. F of x plus h minus f of x divided by h. So this is the difference quotient. So how do I start? What is the thinking process here? What do we do? What do I have to determine? What do I have, what I don't have? Any ideas? Any ideas? How do I start? Do we remember any of this? Okay, so obviously this cannot be simplified any further. It's just a letter. This cannot be simplified any further. It's just this. So this I have, so I don't have this. So that's my starting point. I have to find f of x plus h. How do I find that? What will be the first step? Dictate and I will put it in.
X squared minus 4x plus 3 plus h. To be fair, I just woke up.
I know, I saw that.
Okay, f of x plus h equals difference quotient.
Okay, this is very important. Here's how
All
we
that
look.
Over h?
Here's how we look at the function. F of whatever equals whatever squared minus 4 times whatever and plus 3. Now
Okay.
this should ring a bell, a big one, the Liberty one.
Liberty bell can't ring. It's like in my head.
So, please, other than Tom, I don't want to hear him.
X plus h squared
Very good.
minus 4x plus
Thank you, Eddie, you saved us. Good.
h.
Good, so what now? I need to simplify this as much as possible before I put it in here. Before you say anything, please remember we have an agreement for 3 months and a half.
X squared
Yes?
plus 2xh plus h squared.
Indeed. Thank you very much. So now I have this as well. Now I have all these three pieces. I'm going to put them together. So the difference quotient is, I'm going to copy f of x plus h, which is all this. X squared plus 2xh plus h squared minus 4x minus 4h plus 3. Then I reach the negative sign that will be distributed to all three terms. So minus x squared plus 4x minus 3. And then denominator is h. Okay, so a long time ago, we said this, that two things have to happen here. Do we remember what are those two things that have to happen?
All the terms of h have to cancel out.
The terms without h
Without it.
must cancel out, correct? What is the second thing that has to happen? What do you think? H in the denominator must eventually disappear. Good. So let's take a look. The positive x squared with a negative x squared. Oh, this is not good. The positive 4x with a negative 4x. The negative 3 with a positive 3. How many terms are still left at the top? 1, 2, 3. Very good. What do they have in common?
H.
Very good. I have to pull it out. And that's how the h will go away. How many terms will you give in parentheses?
3.
Exactly 3. Yes. And they are
2x plus h plus 4 minus 4.
very good. Awesome. That's correct. So then, what is the simplified form?
2x plus h minus 4.
Yes. That is the simplified form of the difference quotient for this function. That's it. Very important type of problem. Let's graph a piecewise defined function.
By the way, the final isn't here, right? Not the testing center.
It is here.
Okay. Good.
Yeah, we'll talk about the final in a minute. Just give me one more minute
Good. One.
to look at a function that is a piecewise defined function now. Let's say problem 7D on page 252. We have f of x, and it's given to us as 0 if x is less than negative 3. It's negative x for negative 3 less than or equal to x less than 0. And it's x squared minus 1 for x greater than or equal to 0. This is a piecewise defined function, and it's defined in how many pieces?
3.
3 pieces. Very good. What do we have to determine first?
Where it's defined.
Correct. Its domain. Always. Very good. Well done. Good.
From the looks of it, all real numbers.
Okay. Now I would like to change this into a interval notation. I would like to change this into an interval notation, and I would like to change this into an interval notation. Because I'm going to use those symbols. Bless you. I'm going to use the symbols. So, the interval notation for the first one.
Negative infinity, negative 3. Negative 3, 0.
With a bracket. And
0, infinity.
good. So you're correct. Everything is there. Between negative infinity and negative 3, between negative 3 and 0, and negative 3 at 0, and 0 to infinity. Awesome. So indeed, all real numbers. Which numbers I have to have in the chart, no matter what?
Negative 3 and 0.
Correct. So I have to have negative 3 and 0. Other numbers will be in there. The values of x will be in there in a few minutes, or in a minute. Okay, but what are the symbols under -3? An open parenthesis to the left and a bracket to the right, and they touch. What are the symbols under 0? Same thing.
Parenthesis and then bracket.
Parenthesis to the left and the bracket touching to the right. Which function I will be using for -infinity, -3? I know it's an overkill, but it's safer to have it.
Y equals 0.
Very good. And what about the second interval?
Negative x.
Correct. And what about the last one?
X squared minus 1.
Very good. Awesome. Good. So then let's pick, this is linear, and this is
Quadratic.
quadratic. So here I only need one value. When x is -4, how much is y?
0.
Correct. When x is -3, how much is y?
0.
Correct. Although I'm not really allowed to use -3, I will leave this open as long as this one is a different number, right? Good. In the middle, -3 and 0 are good enough. So please plug in -3 and give me the answer.
Positive 3.
Correct. Please plug in 0 and give me the answer.
0.
Correct. Now please plug in 0 and give me the answer.
1.
Good. And let's also look at 1, because when I plug in 1, I get
0.
correct. That's all we need. You can always determine more ordered pairs if you want to. So now let's graph. Please give me the first ordered pair from left to right.
Negative 4, 0.
Yes. 1, 2, 3, 4, -4, 0. Next one.
Negative 3, 0.
-3, 0, but what type of point will this be? An open point. Perfect. Next point.
Negative 3, 3.
Very good. What type of point is this?
Closed.
Very good. Next point.
0, 0.
What type of point will this be?
Open.
Good. And then I know how to graph. It's a straight line. That's it. Good. The next point.
0, -1.
What type of point is that?
Closed.
Very good. And then?
1, 0.
Good. And now how do I graph this function? Let's graph it in our head with transformations. Right. So it's x squared shifted down 1. Good. It's not a line. Make sure you're not graphing it as a line. So this is the graph of this piecewise defined function. Can anyone give us the range? We established a domain from the beginning, or actually Tom did for us. Now I would like to determine the range. What will you say? What is the range of this function? What do you think?
-1 to infinity.
Very good, awesome. Thank you. The range is -1 to infinity. Very good. Okay. Let's look at some linear inequalities, absolute value inequalities. Something like 62 on page 203. And we have the absolute value of x plus 3 is less than or equal to 4. What type of inequality is this?
Absolute value.
Correct. Good. So there are two types of inequalities with absolute value. How do I translate this one? Because I can't touch anything. I can't move terms. I can't subtract, add, nothing. Nothing. If I don't know how to change this into something I'm allowed to, or I know to solve, then I won't be able to solve. So, how do I change this?
Make 2 equations out of it?
Inequalities, yes, but it depends on the type. because it's less than or equal to 4, I'm asked to find numbers whose distance from 0 is 4 or less. So what do I write? 4 or less. X plus 3 is between
-4. Oh, hang on.
and
4.
4 or less. What is the only step that I have to perform here?
Subtract 3.
Very good. So this is it. -7, 1. Okay, let's take a look at 74. The absolute value of 5x minus 2 greater than 13. Totally different story. Different idea. So what do I do now? So now this problem is telling us this. 13 or more. So this could not be presented like this.
So then,
Yes?
out.
Out, exactly. I just want to present.
-13, positive 13.
So I want 5x minus 2 and 5x minus 2. What do I write?
5x minus 2 is greater than 13.
Awesome.
5x minus 2 is less than -13.
Perfect. So these are the two types of absolute value inequalities. If you have the absolute value less than or equal to a number, you're looking at this. If you have it greater than or equal to a number, you're looking at this. This one is easier because you can solve both inequalities at the same time in a chain. This one is more difficult because you have to separate the inequalities. And the solution will have what symbol? Mandatory. The union symbol, which is not the case here. Good. So here I have 5x greater than 15, so x is greater than
3.
Good. So, and here I have 5x less than -11, which means x is less than.
-11/5.
So then I have to have the solution written with a union symbol. What do I have here and what do I have here?
-11/5.
To the left.
-infinity. -11/5. Union. 11/5. 3. Infinity.
That's it. So these are two different types of inequalities. One that says this and the other one that says this. Okay. Let's look at an absolute value equation. Okay, let's say 71 on page 186. And this is my page 12. 71. 2. The absolute value of 4 minus 5/2 x plus 6 equals 18. After this problem, I would like to talk a little bit about the final exam. Okay, so what do we do here?
Subtract 6.
Absolutely. Thank you.
Divide by 2.
Absolutely. I have to clean it up. Right now, I have to present two options. I can't do anything else to this. This is done. So what are the two options?
The equation inside the
So 4 minus 5 halves x.
Equals 6.
Yes, or
Equals -6.
very good. So these are the only two possibilities. The inside is 6 so that the absolute value is 6, or the inside is -6 so the absolute value is 6. Very good. Awesome. Good. So I have to solve this. I will subtract 4. -5 halves x equals 2. And then I will have to eliminate this. How do I eliminate this fraction? What do I have to do to both sides of the equation to eliminate -5 halves?
Multiply by 2.
-2/5. Right? -5/2 times -2/5 will be 1. So x equals -4/5. Are you with me, everyone? Questions?
I mean, I guess that works if I would have gotten the same.
I know for sure you will. Yes, because you don't have to use...
But, you know, it skips a step.
Right, but you don't have to skip a step.
Right.
Good. So -5 halves x equals -10. By moving 4 to the other side, and I'm going to multiply both sides by -2/5 to eliminate the fraction. So then x equals, and I'll simplify, right? So I get 4. -10/1 times -2/5 is -4.